November 7th, 1943, Carpiquet Airfield, France. Hauptmann Hans-Werner Lerche circles the massive American fighter sitting on the wet tarmac, his engineer's mind already cataloguing impossibilities. The aircraft is enormous. The fuselage alone appears wider than a Messerschmitt 109's entire wingspan. Yet this machine reportedly maneuvers in combat, climbs to altitude, and according to Luftwaffe pilots, refuses to die even when riddled with cannon fire. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Second, Lieutenant William Roach's P-47D-2 Thunderbolt sits intact on enemy soil, its olive drab paint scheme unmarked, except for the new Balkan crows hastily applied by German ground crews. The young American pilot had become disoriented in thick fog during a bomber escort mission, mistaken the French coast for England, and landed at what he believed was a friendly base. German soldiers with drawn weapons had greeted him instead. For Lerche, chief test pilot at the Luftwaffe's Rechlin Evaluation Center, this represents something far more valuable than a prisoner. This is the first complete flyable example of the Republic P-47 Thunderbolt to fall into German hands. Every Luftwaffe pilot knows the numbers. American fighters have been appearing in increasing strength over Western Europe since spring. The Thunderbolt formations fly at altitudes where German fighters struggle to reach them. They dive away from combat faster than anything in the Luftwaffe inventory, and most troubling of all, they absorb battle damage that would destroy 3 Focke-Wulf 190 fighters and continue flying. Luftwaffe ace Heinz Baer, credited with over 200 aerial victories, had reported after one engagement that he watched a Thunderbolt absorb an entire ammunition load from his Focke-Wulf's cannons and machine guns, then simply fly away trailing smoke but still under full control. Other pilots reported similar experiences. 20mm cannon shells that would shred a Spitfire or tear apart a Russian Yak fighter seemed to vanish into the Thunderbolt's massive airframe with minimal effect. Lerche walks slowly around the captured aircraft, his trained eye noting construction details that challenge everything he understands about fighter design philosophy. The radial engine dominates the nose, an 18-cylinder Pratt & Whitney double Wasp displacing 2,800 cubic inches. The cowling alone weighs more than the engine of a Messerschmitt 109. The propeller measures 13 feet across, larger than the props fitted to German medium bombers. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The wings span 40 feet, carrying 8 50 caliber machine guns, 4 per wing, positioned outboard of the landing gear. Lerche opens one of the gun bay access panels and examines the ammunition feeds. Each gun is supplied with over 300 rounds. The weight of ammunition alone exceeds 200 pounds. American pilots can sustain continuous fire for well over a minute, an eternity in aerial combat where most engagements last seconds. But it's when Lerche climbs into the cockpit that the true nature of American design philosophy becomes apparent. The seat is surrounded by armor plating. Steel plates 3/8 of an inch thick protect the pilot's back and head. More armor shields protect the instrument panel. Bulletproof glass, not standard aircraft canopy material, provides forward protection. Lerche runs his hand along the armor, feeling its substantial weight. A German fighter pilot sits in an aluminum shell with perhaps a thin steel plate behind his seat if he's fortunate. American pilots fly in armored boxes that add hundreds of pounds, but virtually guarantee survival if struck by ground fire or light cannon shells. The fuel system reveals even more dramatic differences. Lerche examines the tank inspection ports and finds self-sealing fuel cells throughout the aircraft. The Americans use layered rubber compounds that swell when punctured by bullets, automatically sealing holes and preventing fuel loss or fire. German fighters, constantly pushed to maximize performance and range, have largely abandoned such protective systems to save weight. The Focke-Wulf 190, Germany's finest fighter, carries minimal protection. The Messerschmitt 109, backbone of the Luftwaffe, sacrifices protection for performance. Yet here sits an American fighter that appears to have sacrificed nothing, carrying both protection and performance in a single massive airframe. The instrument panel baffles Lerche with its complexity. American aircraft use a bewildering array of engine instruments, each carefully marked, with red and green sections indicating acceptable operating parameters. The turbo supercharger system alone requires 3 separate gauges. Lerche counts over 30 instruments and controls in the cockpit, double the number in a Messerschmitt 109. The flap control system uses hydraulic actuation with automatic compensation mechanisms that Lerche cannot immediately decipher. He decides these mysteries will have to be solved in flight, at safe altitude where mistakes won't prove fatal. November 17th, 1943. Rechlin Test Center, Germany. The captured Thunderbolt, now bearing Luftwaffe markings T9 plus FK, sits on the ramp awaiting its first German test flight. Lerche has spent 10 days studying the aircraft, consulting with engineers, and attempting to understand American design choices that seem to defy German engineering orthodoxy. The Thunderbolt weighs over 17,000 pounds at maximum takeoff weight, nearly twice the weight of a Focke-Wulf 190. Yet, intelligence reports indicate the American fighter matches, or exceeds German performance, in most flight regimes. How is this possible? The massive engine provides part of the answer. The Pratt & Whitney Double Wasp generates over 2,000 horsepower, 1,500 more than the Daimler-Benz engine in a Messerschmitt 109. But raw power alone cannot explain the Thunderbolt's reported capabilities. At 08:15 hours, Lerche straps himself into the armoured cockpit and begins the startup sequence. The Double Wasp engine catches on the third blade with a deep roar that shakes the entire airframe. 18 cylinders firing in sequence create a sound entirely different from the sharp bark of German inline engines. The propeller's massive diameter means lower tip speeds, producing less noise but moving enormous volumes of air with each revolution. Lerche advances the throttle carefully, feeling the aircraft's weight as it begins rolling. The Thunderbolt accelerates slowly down Rechlin's runway, requiring nearly twice the takeoff distance of a Messerschmitt. But once airborne, at approximately 900 feet, Lerche retracts the landing gear and feels the aircraft transform from lumbering giant to purposeful machine. The initial climb reveals the Thunderbolt's first genuine advantage. Despite its enormous weight, the fighter climbs at over 2,700 feet per minute at sea level, matching the best German fighters. The massive engine and efficient propeller overcome the weight disadvantage through sheer brute force. At 3,000 meters, Lerche begins his first turning trials. The Thunderbolt responds to control inputs with surprising precision. The controls are heavy by German standards, requiring noticeable physical effort, but the response is immediate and predictable. Lerche executes a gentle turn, then progressively tightens it, feeling for the aircraft's limits. The turn rate proves respectable, but not exceptional. A Focke-Wulf 190 or Messerschmitt 109 can outturn the Thunderbolt in sustained combat. But Lerche notices something interesting. The controls remain effective throughout the turn, with no tendency toward departure or snap roll, even as the aircraft approaches its performance limits. German fighters often exhibit knife-edge handling characteristics, rewarding skilled pilots but punishing errors with instant loss of control. The Thunderbolt simply becomes sluggish as it reaches its limits, providing ample warning before approaching dangerous flight conditions. At 6,000 meters, Lerche pushes the throttle forward to test high-altitude performance. The turbo supercharger system, that complex arrangement of ducting and turbines filling the rear fuselage, maintains sea-level manifold pressure even in the thin air. The engine continues pulling strongly, unaffected by altitude that would starve a Messerschmitt's engine of power. This is the Thunderbolt's secret weapon. While German fighters gasp for air above 6,000 meters, the American aircraft maintains full power to well over 9,000 meters. Luftwaffe bomber escort missions require sustained flight at these altitudes, where American bombers cruise protected by their own turbo-supercharged engines. German fighters must struggle to reach these heights, arriving with minimal performance margins just as fresh Thunderbolt formations dive down from above. But it's when Lerche rolls into a dive that he experiences the Thunderbolt's most impressive characteristic. At 7,000 meters, he points the nose down and advances the throttle to maximum continuous power. The massive aircraft accelerates with frightening rapidity. Speed builds past 500 kilometers per hour, past 600, past 700. The airframe remains rock solid, with none of the buffeting or control surface flutter that afflicts German fighters at high speed. At 800 kilometers per hour, faster than any German production fighter can safely dive, the Thunderbolt continues accelerating. The controls become heavier, requiring substantial force to move, but remain effective. Lerche pulls back on the stick, applying steady pressure, and the Thunderbolt arcs out of the dive with crushing G-forces that pin him into the armoured seat. No wonder German pilots report that Thunderbolts simply dive away from combat whenever circumstances become unfavourable. The American fighter can build speed faster than anything in the Luftwaffe, then use that speed to disengage at will. German pilots, flying fighters optimized for turning combat and climb performance, simply cannot follow the Thunderbolt into the high-speed regime where American pilots hold absolute advantage. Lerche levels off at 2,000 meters and conducts gunnery trials against a towed target. The 850 caliber machine guns fire with a sound like ripping canvas, sending over 100 rounds per second downrange. The recoil is noticeable but manageable, and the gun sight remains stable during firing. Lerche fires a 3-second burst, expending 40 rounds per gun, 320 rounds total. The target is shredded. American pilots carry enough ammunition for sustained gunnery. A Focke-Wulf pilot must make every cannon shell count, having perhaps 60 rounds per weapon. A Thunderbolt pilot can fire exploratory bursts, walk his fire onto target, and still have sufficient ammunition remaining for multiple additional engagements. After 50 minutes aloft, Lerche returns to Rechlin with a preliminary assessment that will transform Luftwaffe tactical doctrine. The Thunderbolt is not invincible. It can be defeated, but only by pilots who understand its strengths and systematically avoid fighting on American terms. The aircraft's sheer mass and structural strength make it nearly impossible to destroy with the ammunition loads carried by German fighters. The 850 caliber machine guns, though individually less powerful than German 20mm cannons, deliver such weight of fire that they compensate through volume what they lack in individual projectile power. Most critically, the comprehensive armor protection means that Thunderbolt pilots can absorb battle damage that would kill German pilots outright. December 1943 to March 1944. Rechlin and forward bases, Germany. The evaluation program expands as Luftwaffe commanders demand detailed performance data. Lerche flies the Thunderbolt against captured examples of Allied fighters for direct comparison. He demonstrates the aircraft to frontline pilots, showing them both its capabilities and its limitations. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The tactical briefings reveal systematic patterns. Never engage a Thunderbolt in a diving attack. The American fighter will simply accelerate away, building speed that no German fighter can match. Never pursue a damaged Thunderbolt in the hope of finishing it. The armor and self-sealing tanks mean that aircraft appearing mortally wounded often return safely to base while the pursuing German pilot wastes precious fuel and ammunition. Never assume a Thunderbolt is out of ammunition. American pilots carry such vast ammunition reserves that they can sustain fire long after German fighters have expended their loads. The optimal tactic against Thunderbolts requires forcing them into slow-speed turning combat below 4,000 meters, where German fighters' superior power-to-weight ratios provide marginal advantages. But American pilots, trained to avoid exactly this situation, rarely cooperate with German tactical preferences. Major Günther Rahl, a Luftwaffe ace with over 200 victories, attends one of Lerche's demonstrations and afterward shares his combat experience. The Thunderbolt pilots are well trained and disciplined. They maintain formation integrity and use their altitude advantage to control engagement timing. When we attempt to intercept bomber formations, the Thunderbolt escorts dive from above with such speed that we can barely react before they're through our formation and climbing away again. Oberst Johannes Steinhoff, another high-scoring ace, adds his perspective. The Americans are learning our tactics and adapting faster than we can respond. 6 months ago, we could separate their fighters from the bombers and destroy them piecemeal. Now, the Thunderbolt formations maintain cohesion and use mutual support tactics that make individual victories nearly impossible without unacceptable losses on our side. The captured Thunderbolt reveals the material foundation underlying American tactical success. German fighters are built for performance, accepting minimal protection to maximize maneuverability and climb rate. The design philosophy that assumes that skilled pilots will avoid being hit rather than surviving hits. American fighters are built for survivability, accepting weight penalties to ensure pilot protection even when hit. The design philosophy assumes that pilots will be hit regularly and must survive to gain experience and return to combat. By early 1944, the implications become undeniable. Germany's fighter pilot training pipeline cannot replace losses at current rates. Experienced pilots, accumulated through years of combat, are irreplaceable. Each ace lost represents thousands of hours of training and combat experience that can never be recovered. The Americans, conversely, are building an air force designed to protect its pilots even at the cost of raw performance. Thunderbolt pilots who survive being shot down or badly damaged aircraft return to combat with enhanced experience. The American pilot corps grows stronger month by month, while the German pilot corps bleeds experience with engagement. May 29, 1944. Rome, Italy. Lerche receives urgent orders to retrieve a second captured Thunderbolt before American forces overrun the Italian airfield where it sits. Second Lieutenant Lloyd Hathcock of the 301st Fighter Squadron had become disoriented during a mission and landed at Rome, where both he and his aircraft were captured. The Thunderbolt, serial number 42-75971, had previously belonged to 8 Victory ace George Novotny. It bears combat damage from previous engagements, providing Lerche with the opportunity to examine how the aircraft's protective systems perform under actual battle conditions. The fuselage shows over 30 bullet and shell fragment impacts. Lerche counts the holes, noting their distribution. Several hits struck the fuel tanks, but the self-sealing compounds prevented fuel loss and fire. Multiple impacts struck the engine cowling, but the massive radial engine continued, running despite damage that would have destroyed a liquid-cooled inline engine instantly. 3 hits struck the armor plating behind the pilot's seat. The steel plates are dented, but not penetrated. The pilot would have survived uninjured. This is the Thunderbolt's ultimate advantage, quantified in holes that should have been fatal but weren't. Lerche flies the damaged aircraft from Rome to Rechlin, noting that despite over 30 combat hits, all flight systems remain functional. The hydraulics work perfectly. The electrical system operates normally. The engine produces full power. The aircraft, though bearing the scars of intense combat, is fully mission capable. At Rechlin, engineers conduct destructive testing on sections of the airframe to quantify its structural strength. They fire German cannon shells at the Thunderbolt's wings, fuselage, and control surfaces from combat distances. The results are sobering. 20mm high-explosive shells, the standard armament of Focke-Wulf 190 fighters, detonate against the Thunderbolt's structure with minimal effect. The thick aluminum skin and heavy internal framing absorb blast effects that would tear apart German fighters. The engineers calculate that destroying a Thunderbolt requires approximately 5 times the ammunition expenditure needed to destroy a Focke-Wulf 190. German fighters typically carry 60 rounds per cannon. At 5 rounds required per kill, a Focke-Wulf pilot could theoretically destroy 12 enemy aircraft if every shell connected perfectly. Against Thunderbolts, the same pilot could destroy perhaps 2 or 3 at most, and only if achieving perfect gunnery. The armor testing reveals even more dramatic disparities. The 3/8-inch steel plates protecting the Thunderbolt's cockpit can stop or deflect 20mm armor-piercing shells at combat ranges. The bulletproof glass windscreen, 1¼ inches thick, defeats even 30mm cannon shells unless struck at perfect perpendicular angles. A German pilot sitting in an unarmored Focke-Wulf represents an easy target for American gunners. An American pilot sitting in the Thunderbolt's armored cockpit is nearly invulnerable to anything except direct hits from heavy-caliber weapons. June 12 to 13, 1944. Rechlin-Lars Airfield, Germany. The Luftwaffe conducts a massive equipment exhibition, displaying the latest German aircraft alongside the most significant captured Allied types. The Thunderbolt, bearing its Luftwaffe markings T9+LK, sits prominently among examples of the Messerschmitt 262 jet fighter, the Arado 234 jet bomber, and other advanced German designs. Frontline pilots rotate through Rechlin to examine enemy aircraft and receive tactical briefings. They walk around the Thunderbolt, touching its thick armor plating, examining its massive engine, and comparing its construction to their own fighters. The weight difference is immediately apparent. One pilot remarks that he could probably fit his entire Messerschmitt 109 inside the Thunderbolt's fuselage. Major Erich Hauptmann, the highest-scoring fighter pilot in history, examines the aircraft with an engineer's eye. He notes the comprehensive instrumentation, the carefully designed ergonomics, and the thoughtful attention to pilot survival. This represents a completely different design philosophy than ours. The Americans have built a fighter that keeps pilots alive at the expense of some performance. We've built fighters that maximize performance at the expense of pilot survival. The question is, which philosophy wins wars? Oberstleutnant Walther Dahl, an experienced bomber-destroyer pilot, provides a ground attack perspective. Flying the Focke-Wulf 190 against Russian ground targets, every mission is Russian roulette. One lucky shot from ground fire can rupture a coolant line and the engine seizes within minutes. Or a fuel tank is punctured and suddenly you're flying a bomb. The Thunderbolt's pilot could sustain the same hits and keep fighting, or at minimum make it home for repairs. The briefings include detailed performance charts comparing the Thunderbolt to German fighters across multiple flight regimes. At altitudes below 4,000 meters, German fighters hold marginal advantages in turn rate and climb performance. At altitudes above 6,000 meters, the Thunderbolt's turbo-supercharged engine provides decisive advantages. In diving speed, the Thunderbolt outperforms every German production fighter by overwhelming margins. The ammunition expenditure calculations prove particularly revealing. Luftwaffe armament specialists have conducted extensive ballistics testing, firing captured 50-caliber ammunition at representative aircraft structures. The American rounds, though smaller than German 20mm shells, achieve penetration through sustained volume of fire that German cannon shells cannot match due to limited ammunition capacity. A typical Thunderbolt engagement involves the American pilot firing sustained bursts of 3 to 5 seconds duration, expending 200 to 300 rounds total. The weight of fire overwhelms target aircraft through sheer kinetic energy transfer. A typical Focke-Wulf engagement involves the German pilot firing precise bursts of 1 to 2 seconds, expending 10 to 20 cannon rounds plus machine gun ammunition, attempting to achieve kills through explosive effect of individual shells. The American approach compensates for less skilled pilots by providing ammunition reserves that permit multiple engagement attempts. The German approach demands exceptional gunnery skills because ammunition exhaustion occurs within seconds of sustained fire. When both sides field equally skilled pilots, the American ammunition advantage becomes decisive. When the Americans field less experienced pilots, the ammunition reserves allow them to achieve kills through persistence rather than precision. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Major Hermann Graf, holder of the Knight's Cross with oak leaves and swords, summarizes the tactical reality facing Luftwaffe pilots by mid-1944. "We are flying aircraft optimized for the war we fought in 1940 and 1941, when pilot skill and aircraft performance determined outcomes. The Americans are flying aircraft optimized for the war they're fighting now, when pilot survivability and sustained operations determine outcomes. Their philosophy is proving more effective than ours." The exhibition concludes with Lerche conducting demonstration flights in both the Thunderbolt and a Focke-Wulf 190A8, the latest German fighter variant. The performance comparison, conducted before assembled Luftwaffe commanders and technical staff, reveals the fundamental compromises each nation has made. The Focke-Wulf climbs faster below 4,000 meters, demonstrating superior thrust-to-weight ratio. But above 6,000 meters, the Thunderbolt maintains climb performance, while the Focke-Wulf's normally aspirated engine loses power progressively with altitude. In turning combat at 3,000 meters, the Focke-Wulf completes tighter circles, demonstrating better sustained turn rate. But the Thunderbolt's heavier controls and more stable handling characteristics make it easier to fly near performance limits, reducing pilot workload during intense combat. In a simulated diving attack, the Thunderbolt accelerates away from the Focke-Wulf with such authority that the German fighter appears to be standing still by comparison. By the time both aircraft reach 4,000 meters altitude loss, the Thunderbolt has opened a gap of over 2 kilometers, rendering pursuit futile. Most tellingly, in simulated gunnery attacks against ground targets, the Focke-Wulf exhausts its cannon ammunition within 6 firing passes, while the Thunderbolt continues making effective attacks through 15 passes before ammunition concerns become relevant. The demonstration prompts immediate tactical directive revisions from Luftwaffe headquarters. German fighter pilots receive explicit orders to avoid high-altitude combat with Thunderbolts whenever possible. When bomber interception missions require high-altitude operations, German fighters are directed to use speed and surprise for single attack passes rather than sustained combat. Pursuit of damaged Thunderbolts is expressly forbidden unless the American aircraft is visibly crippled and unable to maintain altitude. July through November 1944. Various Luftwaffe bases, Western Europe. The captured Thunderbolts become part of Wunderzirkus Rosarius, a travelling exhibition of Allied aircraft that visits frontline bases to familiarize German pilots with enemy capabilities. Hauptmann Theodor Rosarius commands this unusual unit, flying captured Allied fighters from base to base and demonstrating their characteristics to operational squadrons. The Thunderbolt demonstrations follow a standard format. Rosarius, or Lerche, flies the American fighter through a series of maneuvers, while German pilots observe from the ground and from chase aircraft. The observers see firsthand how the Thunderbolt's size and weight affect its performance characteristics. They learn to recognize the aircraft's limitations in turning combat and its decisive advantages in diving attacks and high-altitude operations. Several demonstrations include mock combat between the Thunderbolt and German fighters flown by experienced test pilots. These engagements, conducted under controlled conditions with safety observers, validate the tactical guidance distributed to operational units. When German pilots attempt to turn with the Thunderbolt at low altitude, they achieve superior turn rates but cannot maintain the engagement because the American aircraft simply dives away when circumstances become unfavorable. When German pilots use their recommended tactics, climbing to altitude advantage before initiating diving attacks and refusing to be drawn into turning combat, they achieve theoretical victories. But the demonstrations also reveal how difficult this approach is to execute against determined opponents. The Thunderbolt pilot can extend away from danger at any moment, using superior diving speed to escape. The German pilot must achieve perfect positioning on the first pass, or accept that the engagement has been lost. Lieutenant Walter Wolfram, who flies the captured Thunderbolt during several demonstrations, later records his impressions. The cockpit felt enormous and unfamiliar, like sitting in a small room rather than an aircraft. The controls required physical effort that seemed excessive compared to our fighters. But once I became accustomed to the aircraft, I gained tremendous respect for its capabilities. The Americans have built a fighter that forgives pilot errors and brings men home alive. That may be more valuable than the last 10 kilometers per hour of maximum speed we've been chasing. The structural strength demonstrations prove most impressive to frontline pilots. Engineers at several bases conduct live fire exercises, allowing pilots to strafe captured Thunderbolt sections with their own aircraft weapons. The results consistently show that German cannon shells, effective against most targets, struggle to achieve decisive damage against the Thunderbolt's heavy construction. One demonstration at Rechlin involves firing a complete ammunition load from a Focke-Wulf 190A8 at a Thunderbolt fuselage section from combat distances. The pilot expends all 60 rounds from each 20mm cannon and all of his machine gun ammunition, scoring 37 hits on the target fuselage. When engineers examine the damage, they find that while the fuselage section is heavily perforated, none of the hits would have penetrated the pilot's armored cockpit or caused immediate catastrophic failure. The Thunderbolt would likely have been able to return to base despite damage that represented a complete ammunition expenditure by the attacking fighter. This demonstration crystallizes the Luftwaffe's fundamental problem. German fighters carry sufficient ammunition to destroy 2 or 3 enemy aircraft if every engagement proceeds perfectly. But against Thunderbolts, perfect execution might destroy 1 aircraft while leaving the attacker with no ammunition for subsequent targets. The mathematics of ammunition expenditure versus target destruction become increasingly unfavorable as American fighter strength grows throughout late 1944, December 1944 to March 1945, the final months. By winter 1944, Luftwaffe fighter strength has deteriorated to the point where captured aircraft demonstrations become largely academic. Fuel shortages restrict training flights. Ammunition production cannot keep pace with expenditure rates. Most critically, the pilot training pipeline has collapsed under sustained losses that cannot be replaced. The Thunderbolts at Rechlin and other test centers continue flying occasional evaluation missions, but their primary purpose has shifted from tactical intelligence gathering to morale maintenance. German pilots, facing overwhelming American numerical superiority, need reassurance that their aircraft and tactics retain some measure of effectiveness. The captured Thunderbolt demonstrations provide this reassurance by showing that the American fighters have exploitable weaknesses, even if circumstances rarely permit exploitation. Lerche's final flights in the Thunderbolt occur in early March 1945, just weeks before Germany's collapse. He conducts high-altitude performance testing, pushing the aircraft to its operational ceiling above 12,000 meters. At these extreme altitudes, the turbo-supercharged engine continues producing substantial power, while hypothetical German fighters would be gasping at the edge of their performance envelopes. The test reveals what American bomber crews have known throughout the war. The Thunderbolt formations escorting them operate in flight regimes where German interceptors struggle even to reach them, much less fight effectively. The Americans have won the altitude war through superior engine technology, relegating German fighters to desperate attacks from below, where every tactical advantage favors the defenders. During one of these final test flights, Lerche experiences an incident that encapsulates the Thunderbolt's survival characteristics. Flying at over 9,000 meters, his oxygen system fails, likely due to cold weather damage to supply lines. Lerche gradually loses consciousness as hypoxia sets in, his grip on the controls relaxing as oxygen starvation affects his brain function. The Thunderbolt, unlike German fighters that might enter spins or other dangerous flight conditions when pilot control is lost, simply establishes a gentle descent. The stable aerodynamics and benign handling characteristics mean the aircraft essentially flies itself, even without conscious pilot inputs. Lerche regains consciousness at approximately 4,000 meters, where oxygen levels are sufficient for brain function. He finds the aircraft in controlled flight, engines still running smoothly, all systems functioning normally. A German pilot experiencing similar oxygen system failure in a Messerschmitt or Focke-Wulf would likely have lost the aircraft entirely. The less forgiving handling characteristics of German fighters mean that loss of pilot control often results in departure from controlled flight. Lerche's survival in this incident provides final confirmation of American design priorities. The Thunderbolt is engineered to protect pilots even from their own errors or equipment failures. April 1945. Allied forces overrun Rechlin and other test centers. The captured Thunderbolts, some still bearing Luftwaffe markings, are recovered by American troops. Photographs show German ground crews standing beside the aircraft, answering questions from American technical intelligence officers about German evaluation results. The intelligence officers learn that German engineers held profound respect for American design philosophy, even while recognizing its fundamental difference from their own approach. One German engineer, interviewed by American investigators, summarizes the German perspective. "You built aircraft to win a long war of attrition. We built aircraft to win quick, decisive campaigns. Your philosophy proved correct, and ours did not. But the difference was not apparent until years into the conflict, when changing our entire design approach was no longer possible." The production statistics quantify the material disparity. American industry produced over 15,600 Thunderbolts between 1941 and 1945. German industry produced approximately 20,000 Focke-Wulf 190 fighters in all variants during the same period. But the Thunderbolt's superior survivability meant that American pilots flew more combat sorties per aircraft produced, achieved higher victory-to-loss ratios, and returned from missions at rates that German pilots could not match. The Thunderbolt flew over 746,000 combat sorties across all theaters, claiming 3,752 air-to-air kills, while losing 3,499 aircraft to all causes. This represents a loss rate of just 0.47% per sortie, the lowest of any American fighter type and substantially better than equivalent German fighter loss rates. More significantly, the top American Thunderbolt, aces, all survived the war. Men like Colonel Francis Gabreski with 28 victories and Colonel Robert Johnson with 27 victories returned home alive to share their combat experience with subsequent generations of pilots. Contrast this with German aces, many of whom died in combat despite accumulating hundreds of victories. The aircraft that kept pilots alive proved more valuable strategically than the aircraft that achieved marginally better performance specifications. The armor protection statistics reveal the survival advantage quantitatively. American studies conducted after the war determined that cockpit armor reduced pilot fatalities from thoracic wounds by 75% compared to unarmored aircraft. Self-sealing fuel tanks reduced fire-related casualties by similar margins. These protection systems added approximately 800 pounds to the Thunderbolt's empty weight, but the reduction in pilot casualties more than justified the performance penalty. German fighters, carrying minimal protection to maximize performance, suffered casualty rates 3 to 4 times higher than American fighters in equivalent combat situations. The German approach produced marginally faster or more maneuverable aircraft, but it also produced dead pilots at rates that could not be sustained. By late 1944, Germany's fighter pilot corps consisted increasingly of poorly trained replacements facing veteran American pilots protected by comprehensive armor systems. The examination of captured Thunderbolts provided Luftwaffe commanders with complete intelligence about American fighter capabilities, but this intelligence could not change fundamental strategic realities. Germany lacked the industrial capacity to produce heavy fighters comparable to the Thunderbolt in sufficient quantities. German engine technology could not match American turbo supercharger systems for high-altitude performance. Most critically, Germany's pilot training infrastructure could not replace losses at rates that would maintain force effectiveness. The Americans, building aircraft designed for pilot survival and sustained operations, created a fighter force that grew stronger throughout the war as pilots accumulated experience and returned from missions that would have been fatal in less well-protected aircraft. The Germans, building aircraft optimized for performance, created a fighter force that bled experience with each engagement, ultimately collapsing under attrition that superior performance could not prevent. Lerche himself survived the war, unlike many of his fellow test pilots. His memoir, published decades later, provides the most comprehensive account of German efforts to understand and counter American fighter technology. He writes with engineers' precision and pilots' respect about the Thunderbolt, noting both its genuine limitations and its decisive advantages. His assessment, informed by hundreds of hours flying captured Allied aircraft, acknowledges that American design philosophy proved superior to German approaches for the type of war that actually developed. The strength of the Thunderbolt in the dive was particularly impressive, and to this I probably owe my life, Lerche writes, referring to the oxygen system failure incident. The aircraft's forgiving characteristics and structural integrity meant that pilot errors or equipment failures rarely proved fatal. This single design characteristic may have saved more pilot lives than any tactical innovation developed during the war. The captured Thunderbolt program revealed a fundamental truth about aircraft design that German engineers recognized too late to affect the war's outcome. Performance specifications matter less than the ability to bring pilots home alive when the conflict extends beyond initial campaigns into prolonged attrition warfare. The Focke-Wulf 190 was arguably the better dogfighter in specific flight regimes. But the Thunderbolt was the better weapon system because it prioritized pilot survival over marginal performance gains. Post-war technical assessments by both German and American engineers confirmed that the Thunderbolt represented a mature design philosophy suited to industrial warfare. The aircraft incorporated every protection system available to 1940s technology, accepted the resulting weight penalties, then compensated with a massive engine producing power levels that rendered the weight penalties irrelevant. This approach required industrial capacity to produce large engines and comprehensive manufacturing infrastructure to build heavy airframes, advantages that favored American industry decisively. The few Thunderbolt pilots who were shot down and captured reported that their German captors often expressed amazement that the pilots had survived encounters that destroyed their aircraft. Luftwaffe pilots, accustomed to fighters that burned or exploded when hit, found it difficult to comprehend how American pilots could bail out of aircraft that appeared to be completely engulfed in flames. The answer lay in those hundreds of pounds of armor, plating, and self-sealing fuel tanks that gave American pilots precious seconds to escape even catastrophically damaged aircraft. One incident from January 1945 exemplifies the differences between American and German fighter design philosophy. A Thunderbolt from the 365th Fighter Group, the Hellhawks, was struck by multiple 20mm cannon shells during a ground attack mission. The aircraft sustained damage to both wings, the fuselage, and one engine cylinder. Fuel streamed from punctured tanks despite the self-sealing compounds, and hydraulic fluid leaked from damaged lines. The pilot, rather than bailing out over enemy territory, nursed the crippled fighter back to Allied lines, maintaining altitude through careful power management and accepting reduced speed. He landed successfully at an emergency airfield, the aircraft trailing smoke and fluids but still under full control. German ground crews examining the wreckage later, after the area changed hands multiple times, counted over 80 separate impact points from cannon shells and machine gun fire. They concluded that no German fighter could have sustained this level of damage and remained flyable. American industrial capacity meant that the damaged Thunderbolt was simply written off and replaced within days by a factory-fresh aircraft. German industrial constraints meant that damaged Focke-Wulf fighters required extensive rebuild efforts to return to service, tying up skilled technicians and manufacturing resources. The American approach treated aircraft as expendable assets, while protecting the irreplaceable pilots. The German approach attempted to preserve aircraft while accepting higher pilot casualties, a calculation that proved strategically disastrous. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The Thunderbolt's legacy extends beyond its combat record to its influence on subsequent fighter design. The principle that pilot protection justifies performance penalties became standard in post-war fighter development. Modern combat aircraft incorporate armor, redundant systems, and crashworthiness features that add substantial weight but dramatically improve pilot survival rates. The Thunderbolt established this design philosophy through wartime validation that protection saves lives and preserves combat effectiveness. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.